This is a comparison of Epson products that have a power switching function. There are differences in built-in parts and voltage monitoring depending on the product. When considering only this power switching function, the higher performing feature are on the left side. From here, we will explain the differences in the configuration of power switching circuits. This is a typical circuit configuration when switching between a main power supply and a backup power supply in a product that does not have a power switching function. This circuit configuration is called a diode OR circuit, and the diodes are connected to prevent each power source, especially non-rechargeable batteries, from charging and causing a fire or explosion. Diodes can stop electricity from flowing in the reverse direction, but they have the disadvantage that the voltage drops by 0.6 volts when flowing in the forward direction. For example, if a 3.0 volts battery is used, the voltage at which the RTC operates will drop to around 2.4 volts. This means that the battery will become unusable much sooner than if it were simply connected. When the main power voltage falls below the backup power voltage, power is supplied from the backup power, and the backup power will begin to be consumed. It may not be easy to replace a backup power, so you would want to extend the life of your backup power as long as possible. In the case of a diode OR circuit, even if the power supply from the main power is sufficient, a slight drop in voltage can cause the backup power to begin to be consumed. Epson's RTC module includes models equipped with a switch circuit that can remove the disadvantage of diodes. For targeted Epson RTC module equipped with the power switching function, the built-in diode and switch are only built into the main power supply side. If the backup power supply is a primary battery, an external diode is required, as shown in the diagram. The diode is connected to prevent the backup power from charging a primary battery, i.e. a non-rechargeable battery, which could cause a fire or explosion. When the main power supply is turned off or when the main power supply voltage falls below a certain voltage, it will switch to the backup power. At this time, the switch on the main power supply side will be turned off. For these targeted RTC products, we recommend using them in systems where the switching between normal mode and backup mode by turning the main power on and off. The normal mode refers to the mode in which the device operates on power supplied from the main power, and backup mode refers to the mode in which the device operates on power supplied from the backup power. For targeted Epson RTC module equipped with the power switching function, the built-in diode and switch are built into the main power supply and backup power supply side. A diode is built in to protect the battery from reverse charging, and a switch is in parallel with it that automatically turns on and off depending on the voltage conditions. This function allows you to use the battery safely. This diagram shows the state when power is being supplied from the main power. The switch on the main power side is on, so there is no voltage drop across the diode and power can be supplied efficiently. At this time, the switch on the backup side is off and no power is supplied from the backup power. The diode at the bottom of the diagram blocks current from the backup power. In the case of the RX8901CE, voltage is supplied from the main power until the main power supply voltage falls below 1.45 volts. In the case of the RX8901CE, if the main power falls below 1.45 volts or is turned off, the circuit switches from the main power to the backup power. At this time, the switch on the main power side is turned off, and the two switches on the backup power side are turned on. There is no voltage drop due to the two diodes on the backup power side, allowing for an efficient power supply. Compared to a diode OR circuit, there is no voltage drop due to the diodes, allowing for an efficient power supply. It can also reduce power consumption of the backup battery. When using a secondary battery as the backup power, there is no need to provide a separate charging circuit for the secondary battery. When the backup power supply voltage drops below the main power supply voltage, charging of the backup power supply is enabled. At this time, all switches turn on, allowing efficient charging. When the backup power supply voltage becomes the same as the main power supply voltage, charging stops. In the case of the RX8130CE, 3 voltage levels are set for recharging and charging stop, and it is possible to select one of these voltages. Based on the power switching function, Epson's RX8130CE is the best RTC module with this feature. Here is an example of the selection guide flowchart for Epson RTC modules with power switching function. The flowchart starts with determining whether the backup power source to be used as a primary or secondary battery, and then moves on to whether an external diode can be added and whether high accuracy is required even with temperature changes. It takes into consideration the internal circuitry of the RTC module and select an appropriate product. The first R in the product name stands for RTC module, and if the next number is X, it is for consumer and industrial use, and if it is A, it is for automotive use. Also, if the next number is in the 8000s, the interface is I2C, and if it is in the 4000s, it is SPI. This is a comparison table of RTC modules in a 3.2 by 2.5 mm package size that also include other functions. Includes products without power switching function. In addition, it shows the interfaces, maximum operating temperature range, timestamp, external event input terminal, and reset output functions. Please choose the RTC module that is right for your system.